to set up a simulation. You should have read some of the information from your textbook, but it can be a little confusing, so hopefully this will clear things up. Okay, so a simulation is just a sequence of random events. And they model a situation. We will use random numbers that correspond to the true real world relative frequency that we're trying to model. So an example would be flipping a coin, heads or tails. It should land on heads 50% of the time, and it should land on tails 50% of the time. So we would use those percents for heads or tails. If we were talking about a die, then we would say, if I was rolling a die, it should land on a die 1/6 of the time, on a 1, on a 2, and all those, okay? All right, so a component is just the most basic event that can happen. So the most basic event would be the chance that I hit a head, or how many times my coin flips on a tail, okay? The individual result of the component, that is called the outcome. So what happens is you go through this process, you have to identify the components, you have to identify the outcomes, and then what we'll have is we conduct a trial. And we also have to be specific on how we're going to do that trial. A trial is a sequence of several components representing real events that we will pretend to take place. During each trial, the results recorded are the values of the response variable. So depending on what we're trying to simulate, we might have different response variables or different results that we look for, okay? All right, so here's kind of a process to follow. The textbook takes you through a steps 1 through 6 or 7, I believe, but this is kind of briefly the same idea, okay? So the first thing you do is you have to identify the components. Identify all the components and state how you will model the random occurrence of an outcome. So the components are what could happen. So if I'm flipping a coin, it would be a head or a tail. And so maybe heads represented zeros and tails represented ones. Okay? You could make or miss a basket. Or you can make or miss a trash can throw, whatever. Maybe a make is 0 and a miss is 1. It doesn't matter. You just have to say what they are, and it has to be true to the proportion of what really happens. Now, if I constantly practice at my trash can throwing, and I know that I make 75% of the time a basket, a 0 and 1 wouldn't work because this would say I would only make it 50% of the time. So we'll have problems where we have percents that we have to do a little bit more. Okay. So these all have equal chances, and again, if they don't have equal chances, then it's going to be something else. So let's say I am a good judge of the gender that's going to walk through the door first, whether it's a boy or girl, and I say that I can accurately do it 70% of the time I guess correctly. Okay? And so there's either two options that can happen. I can either correctly guess or not correctly guess. So 70% I'm supposed to correctly guess. So 70% is like 7 out of 10. We want to start with 0, though. If you notice, we start here at 0, because if I use the number 10, the number 10 is actually a 2-digit number, and I don't want to do that, because then if I use a 2-digit number for 10, then I have all these other 2-digit numbers that I'm going to have to throw away, like 11 or 72 or 36. Doesn't matter. I'm going to have to throw those away if all I'm looking for is one 10-digit number or 2-digit number. So the best thing to do is say that my correct would be 0, 1, 2, 3, 4, 5, 6, because that's 1, 2, 3, 4, 5, 6, 7. And then my not correct would be 7, 8, and 9 would represent that I was not correct. Okay? Again, you could use whole percents, but then they're just bigger numbers and sometimes it takes longer. Okay? All right, for a trial, there's some things that you need to define about a trial. You need to define what you will do. You need to be specific. What will you do? When will you stop it? Sometimes it's going to say, how many do you do until you get this? Or how many can you get in a row? Or there's different scenarios, so you have to know how long you're supposed to keep going with that trial. Okay? If you're accepting repeats, you have to say repeats are okay. What if a repeat is not okay because it's already been assigned and that number can't come up again? Then you have to say repeats are not counted. What about repeats? And what about numbers that don't fit? If I'm only looking at numbers 1 through 25, you have to state what you're going to do with numbers 26 through 99. So if there's numbers that don't fit into your simulation, you have to say which ones will you throw away. What numbers will you discard? And this may not make sense right now, but after we do 1 or 2 simulations together, and then you're doing some in the class, I think it will make more sense. Okay, so now that we kind of know what we have to do for a trial, now we need to talk about our response variable. Our response variable is, what do we care about? What are we interested in? Are you? What will you count? Okay? And lastly, you have to identify what statistics you're going to use. Maybe you're just going to use count. Maybe you're going to use count. Maybe you're going to use mean. You could actually do a histogram and talk about the spread. Or the distribution. There's a lot of different things you could do. You have to decide at the beginning how you're going to do this. Okay? All right, so let's go ahead and actually do one so it kind of makes sense. Okay, so a basketball player has an 80% free throw success rate. And make sure if you need to pause, you could just ask somebody to pause or to go ahead and pause it yourself. Suppose a basketball player has an 80% free throw success rate. How can you use random numbers to simulate whether or not she makes a foul shot? How many shots might she be able to make in a row without missing? Describe the waiting time simulation of her to shoot free throws until she misses, counting the number of successes. Okay, so before you start any of this, you have to figure out your components. Okay, well, there's 2 things that can happen. She can either make it or she can miss it. According to this, 80% of the time she makes it, so that's 8 numbers. So I'm going to say a make is the numbers 0, 1, 2, 3, 4, 5, 6, 7. That's 8 numbers. She misses it, that's 20% of the time, that's 2 numbers, that's 8 and 9. Now, if you set up your component differently and you say the miss is 0 and 1 and the makes are 2 through 9, you will get different results, but in the end they would equal out. Okay? Your random digit would be a little bit different, but again, when you state this, I have to follow what you state when I grade something because you may set it up differently. Okay. So the next thing I need to do is I need to figure out my trial. So the question is, how many shots might she be able to make without a missing? Well, we're going to start with that. So we're going to count the number of shots. Until she misses. And for us, what we wrote, or for what I wrote, a miss is an 8 or a 9. Okay? For this one, repeats are okay. And I'm going to take single-digit random numbers. You have to state what you're going to do. Single-digit random numbers. Okay? The response variable, is just how many she makes. Number she makes in a row. I'm counting to see how many she makes in a row. Now, we should do multiple trials, and we didn't say that, so we could say complete 5 trials. A lot of times problems are going to tell you complete 10 trials or complete 3 trials. It just kind of depends, but they will tell you what to do. Okay? And then lastly, the statistic. The statistic might be her average number of shots before missing. Because if you're doing multiple trials, you can find out the average shot by looking at those multiple trials. Okay, so let's look at the next part. So using that same information, how would our simulation change if her success rate were only 72%? So that would change the make and the miss. So now our make could be 0 to 71, and the miss will be 72 to 99. Okay? Because you can't go to 100, because 100 would make it a 3-digit number, and now we would take random 2-digit numbers. So that's what we would have to say. So we'd have to change our components, so to identify what they are, and we'd have to say that we're taking random 2-digit numbers. Okay, part B, how would our trial and our response variable change if we wanted to know how many shots she might make out of 5 chances she gets a crucial point in the game? So now we would look at 5 shots in a row. So we would look for number of makes in 5 shots. And so up here we were looking for count until she misses. This one we would find out the percent of time, how many shots she made out of 5. And we do that multiple times. In part C, how would a trial and response variable change if we want to know her chances of hitting both shots when she goes to the line to shoot 2? So when you go to the line to shoot 2, she's already been fouled, okay? And the only way, maybe she missed the first, made it, you're trying to do 2 shots, and it's a make and a make. What percent of the time does she get a make and a make back to back? Oops, you can't see that. And then the last one, how would your simulation change if you want to know her score in a 1-and-1? Here she gets to try the second shot only if she makes the first shot. Okay, so there's a couple different things. You can make it and make the second one, so you could see how many times you would make 2 shots in a row. Or you can make the first shot and miss the second shot, so you would see how many times that would happen. And then you would add these up, because this would be 1 point and 1 point, 1 point and no points. So you can count the number of points that way. Once you do more of these, it'll make more sense. And once we actually start looking at the random digits, that will help also.